on page 83, if you want to highlight the definition, what is a radical function? It's something of the form where you've got y equals the square root of another function. And so we're going to be putting in a bunch of different functions inside of a square root and figure out how can we graph those things, how can we notice some properties that start with them. And the graph that you already know is your basic square root of x graph. And you remember that. Again, you would add an arrowhead onto that. You know some points on there. And we know that the domain is when x is bigger than 0, and the range is when y is bigger than or equal to 0. Now, we've already learned how to do the square root of x plus 4. We learned this in transformations. We would just take that square root graph that we had before and shift it 4 to the left. And you would get this blue graph. Can you see that the blue graph here is just the shift 4 to the left? What we're going to do in this unit, though, is we're going to look for the relationship between the equation inside your function, which is x plus 4, and the square root of that function. And one of the things that's going to be important in that relationship are these 2 points. In particular, what we're looking at in those 2 points are where your y values are equal to 0 and where your y values are equal to 1. Because if something is equal to 0 inside of y equals x plus 4, can you see that it's also equal to 0 inside the square root? In this case, what's the x value? It's minus 4. When I plug in minus 4, I get 0 for y. And when I plug in minus 4 inside the square root, I'm going to get the square root of 0 for y. But because the square root of 0 is equal to 0, that point is going to be the same on both the red graph and the blue graph. The same thing happens when the inside is equal to a positive 1. So when x is minus 3, in your line, minus 3 plus 4 is 1. And so you have the point minus 3 comma 1. When you plug in minus 3 into the square root equation, you're going to get the square root of 1. And of course, the square root of 1 is still 1, so that will also be the same. If you took other points on your graph that's inside, so when I talk about the inside graph, I'm talking about what's inside the square root, which is x plus 4. And I'm talking about the graph, the red one, of y equals x plus 4. If I take another point on my red graph, I can find the corresponding point on my blue graph by just taking the square root of the y value. So my y value is 4. What's the square root of 4? 2. So notice on the blue graph, you have 0, 2. So the most simplest way to describe what we're doing to start with square root graphs is you say, look at your original graph, and all you'll do to find points on your blue graph is square root the y values on your original graph. When you square root the y values on your original graph, you'll notice these 2 points that don't change. When y is 0, because the square root of 0 is 0, and when y is 1, because when the square root of 1 is also 1. So you'll notice those points don't change, but everything else is just the square root of the y value. You'll notice your blue graph has a new domain, because wherever your red graph is negative, your y values are negative, you can't take square roots of negatives, so that'll change the domain of your function. So we're learning a new way to graph square root of x plus 4. The old way, take your square root graph, move it 4 to the left. Right now, that should still be easier, the easiest way to do this one. Our new way is find out where it's equal to 0 and 1, and then take your square root. Now take out your calculator. When you take the square root of a number, Is your answer bigger or smaller than the number you started with? Smaller? Give me an example. Perfect. Square root of 4 is equal to 2. So in our minds, when we take the square root, because of all of our experience with square roots, we almost always get a smaller number. Square root of 36, it's smaller. The answer is 6. Your job with your calculator is I want you to find a square root of a number where the answer is bigger than what you put in. All right, someone tell me an answer they found that was bigger. Any answer. Doesn't matter. 0.1. So if you did the square root of 0.1, yes, 0.3. It's bigger than 0.1. Someone give me another one that they had. 0.9. Doing the square root of 0.9 gives you 0.94, which is bigger than 0.9. So you started to realize a pattern. Did you start to do some other values? Did anyone try 0.5? Square root of 0.5 is 0.707. Anybody recognize that number? No? What mode am I in? Radians. Didn't recognize that that is the same as sine of pi over 4. Whoops. Whew. From your pi plate? Interesting. Okay. How would you find them all? What are all the square roots going to be that are going to be bigger? So you could be confident. Anything less than 1. Good, because as soon as you did square root of 1, you got 1. Now, you have to be a little bit careful here, because if we say anything less than 1, then I should be able to do, let's do square root, number less than 1 is negative 5,843 less than 1. Yes. So my answer should be something bigger than this. Although when I do this, I get an error. Whew. Right? And as soon as you get an error, you just quit. Don't want to continue. So yes, less than 1, but not all numbers less than 1, because, or maybe I just luckily picked the one number less than 1 that didn't work. But what's the problem with that number? It's negative. Can't take the square root of a negative. So less than 1 and bigger than 0. So now we're going to look at our graph. We're going to look at the graph that we were just working on and notice something. Because this is another key thing. Most square roots are smaller than what you started with. In fact, anything bigger than 1, square root of 4, 2, it's smaller. Square root of 9, 3, definitely smaller. Square root of 100, 10. Anything bigger than 1, when you square root it, is less. But anything between 0 and 1 is slightly more. So when we graph this, we're going to find some key points. We're going to find 0 and we're going to find 1. We might find another nice point like this. But when we graph it, we're going to make sure that our blue graph is slightly above between 0 and 1. Because the square root of something between 0 and 1 is going to be bigger. And then after 1, our entire blue graph is below our red graph. So looking at this graph, can you see between 0 and 1, the blue graph is above the red graph. And after 1, so when I'm talking about 0 and 1, I'm talking about our y values here on the red graph. Between 0 and 1 of our y values, our blue graph is slightly above. And then after that 1 value for our y values, now our blue graph is below. And that's going to be an important characteristic that we're going to look at. So here's another graph. This is one you might make a mistake with transformations. Because what would you forget to do in transformations on this one? You have a horizontal reflection and a horizontal translation. You'd have to remember to factor that out. Most people would want to go 2 to the left, when in reality you flip and move it 2 to the right. Can you see that blue graph there as a square root graph being flipped and moved 2 to the right? Yes. But using our new technique, if we graph negative x plus 2, that's a really easy graph because it has a y-intercept of 2 and a slope of negative 1. We get that red line. Once you have that red line, you find out where is it equal to 0? Right there. Where is it equal to 1? Right there. What's another nice point? Well, maybe you choose this point right here, negative 2 comma 4, and you find out that on our blue graph, that would be negative 2 comma 2. Using this idea, everything between 0 and 1 is going to be slightly bigger. Can you see that our blue graph is slightly above? And then everything after is below your red graph. So these important characteristics are what we're going to use for graphing any function inside. We're going to look for where the original function was equal to 0 and 1. We're going to look for other nice points that we can take the square root of. Between 0 and 1, we'll make it slightly above. After 1, we'll make it below. So this is all summarized on the next page here. We can highlight these key ideas. If 0 and 1 are on our original graph, they're going to be on both graphs. And the definition of that are points that don't change, which are called invariant points. In between 0 and 1, we said it was slightly above. That's what this bullet says here. In between 0 and 1, it lies above the graph of the original function. And after y equals 1 is where it lies below the graph. And anywhere where your original graph was negative, your square root graph will not exist. So these are the key characteristics that we saw before, and now we can throw any function we want inside, not just lines. Although we'll start with a couple of lines, and then we'll go from there. So here's example 1. So on these same graphs, we're going to sketch the square root of f of x. We're not going to worry about doing our transformations. We're going to use our new technique. So in our new technique, the first thing you're going to look for are those invariant points. Where is the y value equal to 0, if there is one? Where is the y value equal to 1, if there is one? Well, can you see right here is where my y value is equal to 0. And if I went across from y equals 1, it's not a nice point, but right there is where the y value is equal to 1. Can you do the square roots of any other points? Are there any other nice ones? Well, here, 4 is a nice one to do square root of. Square root of 4 is 2. So I can put that point on my graph. The next nice square root would be square root of 9. 9 is right there, so if I go straight down, square root of 9 is 3. That point would have to be there. Now you have enough points here that you could draw your curve, you could draw your square root going through them. You'd probably do just fine, but we have to be careful because in between 0 and 1, you want your blue graph to be slightly above, and then after 1 to be below. So what I've drawn right now is a good example. Maybe I didn't go right through that point very nicely, but I'm going to show you a couple of examples of things that could go bad for graphing these. And when things go bad, it's because you overreact. So here are some examples of overreactions. It needs to be above. Okay, whoa, that's way too much above. It also goes back in time. That's not good either. Okay, so even if your bubble was like that, that's too much, because we're going back in time here. That can't happen. Another exaggeration that would not be good. Your bubble, whenever you did those square roots of numbers between 0 and 1, it never was above 1. Square root of 0.9 was 0.94. If you did square root of 0.95, it'd be 0.97 or something like that. But it wouldn't ever go over 1. So when I drew this little bubble a little bit too high, that's a problem. Sometimes, based on your graph, you will have very little room to make it above. Right? I don't have a lot of room to make it above. So it's just a little bit. And that would be a nice graph. So we try not to over-exaggerate that bubble above. Sometimes you will find that your line will almost be identical to it, and that'll be fine. But try to make it just slightly above. Okay, so here I'll draw the good one in the end. There we go. Same thing with our second graph. So we'll do the same thing. We want to start by finding where our y values are 0. So I go across from 0. There's where my y value is 0. Where's my y value equal to 1? On this one, do you see that I don't really have any other nice points? Because I never get to 4. Do you know any of your other square roots by heart to a decimal? Square root of 2? Square root of 3? Square root of 5? No? Okay. So if you knew those, you could estimate. Like square root of 2 is 1.41, so you could estimate square root of 2. Square root of 3 is 1.73. You could estimate those if you wanted to. But do you know that square root of 2 and square root of 3 are less than 2 but bigger than 1? Does that make sense? That square root of 3 has to be between 1 and 2. So you could just estimate it that way. Notice that where my y value was 3, I estimated something between 1 and 2. Between 0 and 1, here our graph is slightly above, and then after it's below. So this is the idea of graphing these. And we use this idea whether they're straight lines we start with, or whether they're parabolas or x cubed graphs, or any graph we want, sine graph, inside of our square root, we can now graph them. So the question for this one is number 5.